Seedance 1.5 Pro, a native audiovisual joint generation foundation model.
Big one.
Yeah, this is the one we've been waiting for from ByteDance. We're going to do a deep dive into the technical paper today. We're really focusing on what makes this model different, especially for, professional content.
Right.
So for anyone just looking for the quick summary, the 1-minute version for your short form feed, here it is right now.
Let's do it.
Okay, first, the architecture. Seedance 1.5 Pro is built on a dual-branch diffusion transformer. The key here is native joint audio-video synthesis. They're not just, sticking an audio track on top of a video.
They're born together, intrinsically linked.
Exactly. Second point, quality and alignment. The model gets really superior quality and exceptional audio-visual sync, especially lip sync, from this multi-stage data pipeline and some very meticulous post-training. We're talking supervised fine-tuning and tailored RLHF.
Yep, post-training is huge.
Third, inference speed. This is a big one. They've got an acceleration framework that boosts the end-to-end inference speed by over 10 times. So it's actually practical.
Making it usable, yeah.
And finally, what really makes it different, precise, multilingual, and dialect lip syncing, really dynamic cinematic camera controls, think perfect dolly zooms, and just overall the much stronger sense of narrative coherence.
That's a great summary. And I think it hits on the key shift in the field, right? The industry has gotten pretty good at just high-quality visuals.
Right.
What Seedance is trying to do is solve the hardest problem, which is that genuinely synchronized, production-ready audio-visual output, and doing it fast.
Okay, so let's unpack that, starting with the foundation.
Yeah.
What is the architecture that even allows for this native joint generation? How does it make audio and video feel like one unified thing?
So the core of it is a unified structure based on the MMDiT, the multimodal diffusion transformer.
Oh.
And the key is that dual branch setup. It's not two separate models that are sort of talking to each other late in the game. It's a single unified framework that's designed for this deep inherent cross-modal interaction right from the very beginning.
So that's what guarantees the consistency.
That's what guarantees the semantic consistency and, crucially, the precise temporal synchronization. The model is designed to see and hear at the same time. The outputs are just naturally going to be more coherent.
And I imagine that unified architecture gives it a lot of flexibility, too.
Oh, absolutely. They support it with this multitask pre-training on huge mixed modality data sets, and that provides some serious robustness.
Meaning it can handle different kinds of tasks.
Exactly. It means you get strong generalization across everything, text to video audio, image to video audio, and even the more standard unimodal tasks like just text to video.
Got it. But, a great architecture is only as good as the data you feed it.
100%. And Seedance relies on what they're calling a holistic, multi-stage data curation pipeline. It uses a really advanced captioning system to generate rich, professional-grade descriptions for both modalities.
So it's not just labeling a person is talking.
No, it's more like a woman is speaking with a serious, clipped tone while adjusting her tie. That level of detail for both sound and visuals.
And looking at their priorities in that pipeline, it says a lot about who they're building this for. They're focused on video-audio coherence and motion expressiveness, and they use this curriculum-based data scheduling.
Yeah, that's a subtle but really powerful point. They're basically training the model in stages, moving from simple stuff like visual stability to much more complex, expressive, finished media. It's not just about making quick, flashy clips.
It's like building quality control right into the data diet.
Precisely. And that high standard flows directly into the next big piece, the post-training pipeline. They lay out a very clear 3-stage process. First is the initial pre-training, then supervised fine-tuning, or SFT, and finally, feedback alignment using RLHF.
Okay, and this is where it gets really interesting because they're not just using off-the-shelf techniques. That SFT stage uses these super high-quality, perfectly aligned audio-video data sets, but the RLHF algorithm, it wasn't just borrowed. They engineered it specifically for audio-video.
They had to. And that engineering really shows up in their multi-dimensional reward model. This is a huge challenge in generative AI because different metrics can often conflict with each other.
Right, like if you push for amazing visual detail, you might lose some motion quality.
Exactly. Or if you make the video super stable, maybe it doesn't follow the prompt as well. So they've defined success not as a single number, but across 3 critical vectors at the same time, improving motion quality, visual aesthetics, and audio fidelity.
That sounds incredibly difficult to optimize for.
It is. They're essentially grading the output on how it moves, how it looks, and how it sounds, and then training the model to find the sweet spot in that three-dimensional space.
Yeah.
It's way harder than just optimizing for one thing.
And they optimize the infrastructure, too. I saw they got a nearly 3x improvement in the RLHF training speed.
Which is just monumental. I mean, when you think about the scale of this data and how many iterations you need for reinforcement learning, a 3x speedup is a massive economic advantage.
Right.
That lets them iterate and improve the model way faster than their competitors might be able to.
Speaking of speed and viability, that brings us to the inference acceleration. Because for any kind of high-end production, speed is everything.
It's completely non-negotiable.
Yeah, waiting hours for a few seconds of video is fine for a research paper, but it's a non-starter for a studio.
Right. So to solve this, they focused on optimizing a multi-stage distillation framework. The main goal here was to drastically reduce the number of function evaluations, or NFE.
And for anyone listening, NFE is basically the number of steps the model takes to refine the output.
Exactly. Fewer steps means faster generation, as long as you can maintain the quality.
So they're telling the model to get to the same high-quality result, but in way fewer steps.
That's the idea. And the end result, when they integrated this with other optimizations like quantization and parallelism, was an end-to-end acceleration of over 10x.
Wow.
And that's crucial. That's what moves Seedance from being just an interesting research project to a genuine production tool where speed and quality aren't mutually exclusive.
And if you're going to build a production tool, you need a production-level way to measure it. Which brings us to their evaluation framework, Seed Video Bench 1.5. They're moving beyond the standard academic benchmarks here.
Yeah, this is a really clear signal that they're serious about industry adoption. They worked with professional film directors and industry experts to build this benchmark.
So it covers things that other benchmarks might miss.
Exactly. Things like high-impact advertising or short, complex microdramas. By getting cinematographers involved, they're making sure the human evaluations aren't just about pixel quality, but about actual cinematic utility.
Okay, let's break down these new evaluation dimensions. For video, it covers the usual stuff: subjects, motion, but adds really detailed labels for things like complex camera movements.
And the really big update, given the model's focus, is the audio dimension. The taxonomy now breaks down human voice types, separating speech from singing, and even voice attributes like timbre, accent, emotional tone.
And it handles non-speech audio, too.
It does. Sound effects, music. And what's, I think, revolutionary for a joint model is that for image-to-video generation, the audio is explicitly conditioned on the visual cues in the starting image.
So the sound is driven by the picture.
Precisely. The sound isn't random, it's visually mandated. An explosion sound will match the visual size and timing of the fireball.
That makes sense. Now, looking at the actual metrics, they've updated how they measure video quality. They're moving beyond just stability.
They are. The definition of motion quality has been upgraded to emphasize what they call video vividness. And I think this is a direct response to a known trade-off in the field.
The slow motion trick.
The slow motion trick, yeah. Some competitors generate in slow motion to make the video look more stable, but it ends up feeling dull and, frankly, lifeless.
So video vividness is broken down into an action dimension, focusing on nuanced facial expressions, fine-grained motions, and a camera dimension for cinematic composition and dynamic movement.
They want motion that's both expressive and stable, not one or the other. And their definition of prompt following has also evolved.
How so?
It's less about strict keyword matching now, and more about consistency with the user's underlying intent. Which, if you think about it, is what a professional tool should do.
Yeah, you don't want it to fail just because you phrase something slightly wrong.
Right. You want the model to complete the scene logically, even if that means it has to fill in some missing details, as long as it serves the core narrative. It gives the model a bit of creative license.
Which is what a high-level user wants. Okay, so on the new audio metrics, what are they measuring there?
The most important one is probably audio-visual synchronization. This measures the temporal alignment of speech to lips to get rid of that distracting ventriloquism effect and the timing of sound effects to visual events.
So in hands clap, the sound hits at that exact microsecond.
That's the goal. And then there's audio expressiveness, which goes beyond just clarity. It's evaluating emotional resonance, if the background music fits the theme, and how the audio overall adds to the narrative depth. It's really a measure of artistic contribution.
And when you look at the results, the data seems to back this up. Against competitors like Kling and Veo, Seedance 1.5 Pro takes a leading position in text-to-video prompt following.
Yeah, that shows their alignment work paid off. But the joint generation really shines in the audio comparisons, the good, same, bad preference tests.
Right.
Seedance excels in synchronization. It's better than BO and Kling on general audio alignment, and especially on lip sync. It even accurately matches the audio to the number of people speaking in the scene.
And we have to talk about the Chinese language performance.
Oh, for sure. As a model from ByteDance, you'd expect this to be a focus, but the execution is just really, really good. It consistently outperforms competitors in generating Chinese dialogue, dialects, monologues. The clarity is high, and it avoids a lot of those common artifacts like dropping syllables.
Which brings up an interesting comparison with a model like Sora 2. Sora is known for this incredibly vivid, almost volatile emotional output.
Right.
Seedance, on the other hand, seems to aim for a more balanced and controlled expressiveness.
And that's not a limitation. I think that's a very intentional design choice for their target audience. For professional production, a director needs predictable, stable tone control. You want reliability over, say, maximal emotional exuberance.
So what does all this mean for an actual creator? Let's talk about the features that translate directly to a production workflow. The cinematic control is pretty impressive.
It is. The model can handle autonomous camera scheduling. It's not just creating static shots. It can reliably execute complex movements, orbital shots, arc shots, long takes, even that tricky dolly zoom all, while keeping the visual style consistent. I mean, think about the time that saves an animator.
And the narrative strength you mentioned earlier is key. The semantic understanding lets the model introduce new things into a scene, but they always stay aligned with the genre.
Yeah, if you ask for a noir detective scene, you're not going to get a cartoon rabbit hopping through. It maintains the tone.
Beyond that, the specialized Chinese language stuff offers tools for really culture-specific content, and it's deeper than just getting dialects right.
Much deeper. They've shown a heightened sensitivity to traditional Chinese performance. For example, it can capture the unique cadence of operatic speech, which is called nianbai.
And for our listeners, nianbai is a very stylized, rhythmic way of speaking in Chinese opera. It's not normal dialogue. Synthesizing that accurately requires some deep cultural context.
It really does. And the model even gets nuanced physical details. They specifically called out its ability to synthesize the Dalanhuazi, the orchid hand gesture, which is a really key symbolic movement in traditional performance.
Wow.
Yeah, it even captures the stylized eye expressions for specific comedic or dramatic roles.
So it's not just generating a person, it's constructing an entire performance atmosphere that's rooted in a very specific cultural and artistic tradition. That's a huge leap.
It is. And then you have the character close-ups. The model can sustain emotional continuity through these subtle facial micro-expressions. So even with minimal dialogue, the character's emotional state stays consistent, which lets creators use silence and nuance effectively.
So to wrap this up, the immediate plan is platform integration. They're positioning this as a productivity tool to be integrated into platforms like Dubo and Jameng by December 2025.
And that positioning, I think, raises a really important final question for the whole community. Given that Seedance is prioritizing this balanced, stable, and controlled expressiveness for production.
Right, in contrast to models like Sora 2 that are pushing for maximum emotional vividness.
Exactly. So how is the industry ultimately going to define the optimal level of expressiveness? Is this controlled profile a clear advantage for stability in large-scale production? Or is it maybe a temporary trade-off that will be solved once models can achieve both extreme vividness and perfect control?
That's a great question. The tension between creative control and raw expressive power.
That's the tension to watch. It'll be fascinating to see where the industry lands.